Yo, good morning, it's Miss Power. I'm here to make the review for the Module 2 test. We're going to go over this on Thursday, right? I'm going to give you a printed copy and we'll spend all hour doing this review together. But here's the video early, in case you wanted to start early and then come Thursday with questions rather than develop questions on Thursday. All right, let's go through it. We've got part 1, multiply to write each quadratic in standard form, then identify A, B, and C. This, I probably should have used the verb expand, right? Because I want you to expand each of these statements. All right, basically we're distributing. We've got 4x times 2x, which gives us 8, because the numbers 4 and 2 multiply to 8, and then x squared, because there's 2 x's multiplied together, which gives us x squared. Then if we do 4x times 3, again, those are both positive numbers, so we put a positive. The 4 times 3 is a 12. Let me push this back a little, yeah, sorry. And then there's 1x, so we'll put an x. All the x squared stuff, all the coefficient in front of x squared is a. So if there's 8x squareds, we should put an 8 for a. The b is the coefficient in front of x. And then the c is just the numbers in the back, but this one has no numbers in the back, so the c is 0. Let's do it again. 3x times x is 3x squared. There's 2 x's, so it's x squared being multiplied. 3x times 1 is just itself. 6 times x is 6x. And 6 times 1 is 6. The reason I'm doing it in these different colors is I'm saying everything with 2 x's being multiplied together, so x squared is in one color. So I can see that a should be 3. Everything in light blue has 1x, and the coefficient should be b. And then everything in dark blue is just a number, and that will be a 6. Let's do that one again. This one, x times x is x squared. X times 7 and 3x are both going to give us just x terms. And then 3 times 7 is going to give us our c term. Nope. C term. These ones are going to add together to become 10. We are going to do it out anyways. And the x squared just comes down because it's not being added to anything else with an x squared. If there's only one of these, like there's no number out front, there's only one of them, we put a 1. All right, and then for these ones, when there's a number out front, a lot of people ask me, should I multiply the 2 to all 4 things or just to the first one? You should just do it to the first one. So when there's a number out front, when there's an a term out front, you should do the 2 times the x and the 8, and then just rewrite the x plus 2. Then we do it as normal. 2x squared, 2x times 2 is 4x now. 16 times x is just 16x. And 16 times 2 is 32. So the c is 32. The a is 2. And the light blue b becomes a 20. Cool. Complete the square to rewrite each quadratic in vertex form. This is when we're trying to get perfect squares, right? Complete the squares when we're trying to get perfect square trinomials. So this is when I say, all right, vertex form looks like this. I'm actually going to erase this because I don't know if it's going to be a plus or a minus yet because I haven't looked at the question. So vertex form, whenever I see I want vertex form, I'm always going to write in this pattern. And now I'm actually going to do it. Vertex form is I rewrite the a, and if there is no a, I can either erase it or write a 1. I divide b in half. I square it off to the side, and then I do -6 minus whatever that thing squared is. And that's my answer. And so again, I did, when there was no a, so when a equals 1, I did b divided by 2, and that became my h. And then I did c minus b divided by 2 squared, and that became my k, where this is h, and this is k. You'll notice that I did not flip any signs. When I'm dealing with two equations that are equal to each other, I'm not going to flip any signs. It's when I find the vertex is when I get to flip the sign. But I haven't found the vertex yet, like the actual point, the vertex. I've just found vertex form. So when I'm not finding the point, the vertex, I don't flip any signs. All right, when there is a number up front, here's what we do. First, we divide everything by 3. We write the 3 out front. Then we still divide by 2. We still square it. Then I can do one of two things. And I'm going to do the thing that we've been doing forever, which is I want to do 18 minus whatever I got here, but I need to do 3 times whatever I got here, because basically the perfect square with 10x and x squared is going to have 25 off to the corner, but I've got 3 of them. So I'm going to do 18 minus 75. I'm not really going to do that in my head because it's early. So I'm going to get -57. If you want, you can find the difference between these two and then multiply it by 3, but I recommend doing this because it's what we've been doing. So we're feeling good. Nice. Factor the following quadratics. All right, there's 2 special ones. I'm going to do them first, and then I'll do the rest. This one has no c term, right? C is equal to 0 here. And when c is equal to 0, the x is a factor, right? So I think we should have either this, or even better, this. Actually, I'm going to insist on the second one. What's happening here is that each of these terms has an x, right? So I get to bring an x outside of the parentheses by saying every one of these had an x, so let me reverse distribute or factor out the x. And then each of these also divides by 3, right? 3 divides by 3, and when I put a 3 up front, this just becomes a 1. And sorry, y'all. And 21 divides by 3. When I do 21 divided by 3, I get 7. That's when there's no number on the back, when the c is equal to 0. The other wacky one is when there's no number in the middle, when the b is equal to 0, and there's no x term. This one in our notes, we said it always looks like this, where it's the same number twice, one is positive and one is negative. And when we multiply these a's together, we'll get 49. So when I look at this, I immediately think this should be x minus 7, x plus 7. When we multiply this out, we get x squared plus 7x minus 7x minus 49. And the plus 7x and the minus 7x cancel each other out. Right. These next 3 are what we think of as quote-unquote normal. Oh, I need some coffee. These are the normal ones, or when it says factor, it looks like this. And we're looking for 2 numbers that add up to 7 and that multiply to 12. Once we find those 2 numbers, we're just going to put them right there. And we're done. So let's do it again. We're looking for this format we've got two numbers that add to a certain number and two numbers that multiply to a certain number. To be honest, we're about to do this again, so I'm just going to copy and paste this right here. Okay, we're looking for two numbers that add up to -8 and multiply to +15. If you're multiplying to a positive number and adding to a negative number, I think both of these numbers should be negative. If we try -3 and -5, turns out it works. So I want -3 and -5 as my answer. Let's go again. Add to +5. Multiply to -24. These ones, I'm going to do it out. I'm going to write all the factors of 24, and I'm going to know that they're all the factors because I'm going to try 1 first. I'm going to try 2 next. Nope. I'm going to try 3 third. I'm going to try 4. I'm going to try 5. It won't work. I'm going to try 6. It does work, but I've already written it. So now I know that these are all the factors of 24. I know I want to add to a positive number. So I'm going to add negatives on all the small numbers so that when I add them together, it's still bigger than 0. And then I'm going to check which one of these adds up to 5. Turns out it's -3 and 8. And we get our final answer. The next three, one of them is like quote unquote easier because the A term divides all of the terms. So for this one, excuse me, I can rewrite this as 2x squared plus 9x plus 20 because each single one of these terms, A, B, and C, divides by 2. And now my answer looks like this, where I'm trying to add to 9, and I'm trying to multiply to 20. Right, if we want to add to 9 and multiply to 20, it should be 5 and 4. And then our final answer should have a 2 out front to say, actually, our question was twice as big as what we're describing. So this one, I think, is like one step away from being exactly like the 3 we just did. Whereas F and G are not quite like that. This is the Xbox method. This is the thing where we're doing a little bit more difficult. So we're going to put our final answer here. We'll erase this so it looks nicer. Good. We are still eventually asking if we're adding to something and multiplying to something. Let me take this off for now. But then there's more of a question of what comes after that. So we've got this box thing that we're about to populate. And then we'll take the side lengths as our final answer. So here's my setup for F and G. I'm going to go ahead and set up G as well. I still want two numbers where we're adding to something and multiplying to something. And then we're eventually going to use this box. Okay, if we look at our notes, step 1 was write the A term and the C term of our original question into this box. Step 2 was we want to find two numbers which add to 15 and multiply to A times C. Right, so this is going to be, we're going to add to 36, or multiply to 36 and add to 15. Is this true? Times 2, it's 36. Okay, so now let's find all the multiples of 36. 36 is 1 and 36. It's 2 and 18. It's 3 and 12. We can stop. because this one already adds to 15. There are more factors of 36, but we don't care about them because we already found the ones that add to the thing we want. 3 and 12 are not our answers. They don't go here. They go here. And now, to find our answers, we have filled in these two by looking at our original equation. We filled in these two terms by looking at what we're adding and multiplying to. And now I want to say, all right, 2x squared was definitely x times x. And, wow, they're definitely going to make me do fractions. This is too bad. Oh, no. I messed up. Thank God. This should be 15. It should be 12, right? Yeah, these two numbers go here and here. Not what we're adding to. Cool. Okay, 2x squared is definitely x times x. We're going to put the 2 here because we know we're going to do 2x times this to get 12. And if we had put the 2 here, we would have to do 2x times this to get 3, and that would be a fraction. 2 here, this will be a positive 6 because 2x times positive 6 is positive 12. 6 times 3 is what gives us 18. And then we can check this last one. And we should have erased this too after I did the example. We can check the last one, which is good, because x times 3 really is 3x. Now that I've filled out the side lengths for my new box, I get to use those as my answer. So x plus 6 is the top, 2x plus 3 is the bottom, and this ends up being my final answer. And so we did on Friday and on Monday. And I'll probably go over it again today. All right, for G, same thing. I try to divide everything by 3. It does not work. And now I've got to do this method. I immediately write 3x squared and 28 in my two first boxes. I come over here. I say I want to add up to 25 because I still want to add up to B. And I want to multiply to A times C, which is 3 times 28, which is 84. So now I want to find all the factors of 84 and stop when I add up to 25. All right, so 84 is 1 times 84 is 2 times 42. It is 3 times 28. Am I adding up to 25? Let's do it. Okay, 4. I think it's probably this one. Yeah, 4 times 21. These two add up to 25. So I'm going to put 4 and 21 here, 4 and 21 here, 4x here, and 21x here. Now my next step is figuring out which of these should have the 3 and which should have the x. I think the top one should have the 3. So this bottom side one can be 7. This could be positive 4. Let's check. 3 times x is 3x squared. 4 times x is 4x. 4 times 7 is 28. And 3x times 7 is 21. So now we get to put the top and the side lengths as our final answer. Again, I don't want to do this method for E, right? I don't want to do this box thing. I don't want to do the A times C because I can divide all of these by 2 and then just do it normally. All right, graph the following quadratic equations. You'll see they're in 2 different forms. The first thing I'm going to do is make sure they're in vertex form. So if it's in vertex form, I'm good. I get to write my vertex. I get to say when I go over by 1, I go up by 3 here because there's a 3 out front, and I multiply 1 by 3. When I go over 2, I go up by whatever 4 times 3 is, so 12. Then I'm going to put some of these bad boys in. Some axes. Get my brush, I go over 4 up 2. Over 1 up 3. Over 2 up 12, and let's be really careful about this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I draw my parabola, knowing that Miss Power is grading these 5 points. I'm not grading anything else. And now I can talk about transformations. The transformation, okay, so vertex 4-2, got there. Right? Transformations are me saying, okay, from the original, this one moved over to the right by 4. It moved up by 3. It went up by 2. And there was a vertical stretch by 3. The right and up are just saying where my vertex is, and my vertical stretch is saying how much I multiplied my over 1 up 1 stuff by. Here, when I'm given factored form or standard form and I want to graph it, the very first thing is I'm going to change it into vertex form. So I'm going to complete the square. Over here, I have x minus 4x plus 2. I'm going to multiply that out into x squared plus 2x minus 4x minus 8. Which book? Minus 2x minus 8. This is my standard form. This is my factored form. And then I'm going to complete the square. So I'm going to have minus 1 squared, because I did minus 2 divided by 2 and got minus 1. Minus 1 squared is positive 1, which means I need to move down by 9 in order to end up at negative 8. Or I can think of this as negative 8 minus 1. And now I've got my vertex form of the equation. I now know from the vertex form, my vertex is 1, negative 9. I know from my standard form that my y-intercept is 0, negative 8. And I know from my factored form that my x-intercept is 4 and negative 2. And now I can draw my graph. There's no vertical stretch, so I just do the regular up over thing. It's going to be 1, negative 9, so let's go like this. 1, 3, 6, 9, over 1 up 1, over 2 up 4. If I want to, here as well. One more. Graph the following. 2 more. This is when I give you a graph and you have to give me the equation, rather than the other way around. The vertex is either the lowest or highest point. The axis of symmetry is the line that goes right through your parabola. The vertical stretch is when I go over by 1, how far up did I go? This is exactly your A number. So I think the A here is 1. I switch the sign for my x vertex, and I keep this the same as the y part of the vertex. Always knowing that my equation in vertex form will be this. I also want this in factored form. Factored form, I can multiply this out into standard form and then factor it. You can go for it if that's your pleasure. But I also can say where the x-intercepts are is exactly my factored form. So if my x-intercepts are at 2 and 4, I switch the signs because it's inside parentheses and make the factored form x minus 2, x minus 4. And we'll talk about that on Tuesday. Today. All right, now the last one. I want to do everything. I'm given an equation in standard form. I want to factor it. So I think what adds to 8 and multiplies to 15. I want to write this in vertex form, which means I take the a out front. There is no a. I divide this in half. I get 4. 4 squared is 16, so I need to go down 1 to get to my actual thing. I can graph this. Yo, I'm almost done this video, like maybe 2 minutes. Sorry. That's my roommate. I can use my vertex form to know that the vertex is -4, -1, -4, -1. There's no a term out front, so I do my normal over 1 up 1 pattern, over 2 up 4 pattern. I can check my x-intercept by looking at factored form. I want. And the key features, the vertex was -4, -1, and I got that from vertex form. The line of symmetry was x equals -4, and I got that from the vertex. The y-intercept was 15, and I got that from standard form. And the x-intercept was -3 and -5, which I got from factored form. Y'all, that's it. If you've got more questions, you can ask me in class today, tomorrow, Thursday, or after class on Wednesday. See you soon.